This video is going to show you how factoring can help you solve quadratic equations. We're going to use something called the greatest common factor in order to help us factor out these quadratics and then solve them. So what is a greatest common factor, a GCF? Well, it stands for the greatest common factor, a number that evenly divides all terms. So if we're looking at the first example here, 9x squared plus 3x minus 18, we look and see what is the biggest number that divides into all these things. And I see that 3 is the biggest number that divides into all these things. So since our GCF, our GCF is going to be equal to 3. That's what we write. And it's kind of like we're sucking a 3 out of each of these. We're sucking him out. And that's what the 3 is on the outside the parentheses is going to be. So if I yank a 3 out of the 9, 9 divided by 3 is 3x squared. 3 divided by 3 is 1x. Negative 18 divided by 3 is 6. In case you want to make sure that you got this right, just go ahead and distribute. And if you get these same exact numbers again, then you're correct. But mind you that this is our answer, factored out. Okay, and the other one, I look at the 7 and the 21, and I figure out that the GCF is going to be equal to 7. And so that means a 7 comes outside. And so what is 7 divided by 7? It's 1p squared. What's 21 divided by 7? That is 3. And remember, this 7 is going here. We don't write two 7s. The 7 is coming outside. So there we go. That is GCF factoring. So now we're going to start talking about trinomials. In Algebra 1, you guys learned that you can FOIL. Factoring trinomials is like backwards FOILing. So what we're going to do is try to figure out what are all the combinations that make 8. Well, I can do it with 1 times 8, or I could do it by 2 times 4. And so now I have to figure out, well, which one of these would give me 6? Is it 1 plus 8? Or is it 2 plus 4? Well, this one doesn't work. This is the one I want. So 2 and 4 are going to go into my factors. So we write 2 sets of parentheses, 2 and 4. The way to get a positive 6 and a positive 8 is to have both positive numbers. And then how do you get x squared? With x times x. If you want to check to see that you factored it correctly, you can go ahead and try to FOIL, and you should end up with the problem you started with. Like x times x is x squared. X times 4 is 4x, and 2x makes 6x, and 2 times 4 is 8. So you can check to see if it works by trying out FOIL. That's just a way to check it. There is another way to do it, and it's called the magic X. It doesn't really teach you all the possible ways and a more deep understanding, but it is a fast way to factor. The way the magic X works, it works like this. We're going to put the last number on top and the middle number on bottom. And that's called our C number, our B number, and our A number. Our A number is 1 right now. So on top we put our C number, and on bottom we put our B number. Okay, now I have to ask myself, what two numbers add to make the bottom, but multiply to make the top? And so I have a few options. I could try 1 and 32, but I don't think that's going to add up to 12. How about 8 and 4? 8 times 4 is 32, and 8 plus 4 is 12. So these are what's going to go into the factor. Our two factors are going to have an 8 and a 4. They're both positives, and we put x in front of both. And there is our factored out trinomial. So let's try that one more time. Magic X, 24, negative 11. So I have a couple options. I might use 2 and 12. I might use 3 and 8. I might use 4 and 6. All of these are going to multiply to make 24. Now, but only one set is going to make negative 11. 12 plus 2, about 14. So no. 6 plus 4 is 10. No. 3 and 8, that's 11. So that's what we want to use. 3 and 8. Now, how's it going to make our negative 11? Well, they're both going to be negative. And if I multiply two negatives, I get positive 24. So now I write out my x and our minus 3 and x and our minus 8. And there's our factored out problem. Now, what do you do when the number in front of the x squared or the a number is bigger than 1? It doesn't, magic x does not work normally. So remember, this is our a, our b, and our c. So if I think about all my possible factors, I'm going to make these a little bit bigger. If I think about all my possible factors, there's only one way to get 2x squared. Yes, we need an x and an x, but we will need a 2x. There's a couple ways we can get 12. Maybe it's going to be 2 and 6, or maybe it's going to be 3 and 4. And so really we're going to have to just try and see what works out. So let's try 2 and 6. That multiplies and makes 12. And everything in here is positive, so I can count on plus signs here. So now let's check. 2x times x is 2x squared. And 2x times 6 is 12x. 2 times x is 2x. And 2 times 6 is 12. And I add those two in the middle, and I get 14x. That's not what I have. I have 11x. So that is not going to work for us. We've got to back that up. And 2 and 6 doesn't work. Now I could try 3 and 4. I could try 1 and 12. I could try a couple things. So let's try, how about 3 and 4, like this. So again, 3x and 8x makes 11x. There we go. So this is my correct answer. So this is the correct answer. Now, there is a way to use the magic x, but it's a little funky. But I will show you how to do it so you have a couple of different methods. The way you do it is you draw your big magic x, but this time we add another line right here. On the top of our magic x, we are going to put a times, and on the bottom we're going to put b. On one part we're going to put ax, and on this part we're also going to put ax. So now let's start filling in the information. Ax is going to be 4x. A times c is 4 times negative 3 is negative 12. And our b is 1. So we still work on that same process. What adds to make 1 and what multiplies to make negative 12. And when I think about that, I think I'm going to go with 4 and 3. And to make 1, I'm going to make this into a negative 3. 4 plus negative 3 is positive 1. 4 times negative 3 is negative 12, so it works. Now, at this point, what I have to do is I have to look for anything that reduces. So now I'm looking at these two problems right here. 4 and 3 don't reduce like a fraction, but 4 and 4 do reduce like a fraction. So 4 and 4 goes down to 1. And so now I have an x and a 1, x plus 1, and the other one is 4x minus 3. Now, if you don't like this method, you can use the other method on the other slide. Both are just as acceptable as the other. Now, the whole point of doing this is to use these for solving. So, let's go ahead and try to solve out this equation by factoring. So, factor it out like we've been doing. So, x with something and x with something else. 14 comes from 7 and 2. And to get negative 14, one of them has to be negative. But to get positive 5, I'm going to put plus on the bigger one and negative on the second one. Now this is still equal to 0. Okay, that's important to know. I haven't got rid of that equal to 0. Now that I have this, it kind of splits into two problems. The first one is, what if x plus 7 is equal to 0? And what if x minus 2 is equal to 0? Well, if x plus 7 is equal to 0, x would have to be a negative 7. If x minus 2 is 0, then x is going to have to be equal to 2. And these are our answers. Two answers. Whenever you factor a quadratic for solving, you end up with two answers. So let's try out this one. For sake of using the two different methods, let's use magic x on this one. There's a magic x. 2 times negative 8 is negative 16. 6 goes on the bottom because it's the b number. 2x goes on top for ax, and 2x goes on top for ax again. Here's your little guides in case you want to know where everything goes. Now, to make negative 16 and make 6, I could use 4 and 4 to make 16, but 4 plus 4 is 8, and 4 minus 4 is 0, so it's not going to make 6. So maybe it's going to be 8 and 2. And to make 8 and 2 add up to 6, it's going to have to be a negative 2. So I look and see, can I reduce any of these things? I can. Right here, I can reduce 2 and 8 down to a 1 and a 4. I can reduce the 2 and the negative 2 down to 1 and negative 1. So now I'm left with a 1x plus a positive 4 and an x minus a 1. Remember, this is still equal to 0 because that equals 0 right now. At this point, this is where you split this into two different problems. What if the x plus 4 is the thing that makes 0? Or what if the x minus 1 is the thing that makes 0? If x plus 4 equals 0, then x would have to be a negative 4. If x minus 1 equals 0, then x would have to be a positive 1. And there are our two answers. Okay. I hope you understood. If you have questions, leave them in the comment section, and I'll see you in class.